Good morning, guys. This is U2 L5, solving systems of linear equations using tables and graphs. You will need a calculator to help you with the tables, unless you want to do it the long way. That's up to you. All right. So today, students will be able to determine the solution to systems of linear equations with two variables by graphing and by tables. Let's take a look at our ACT questions of a day. A car averages 27 miles per gallon. If gas costs $4.04 per gallon, which of the following is closest to how much the gas would cost for this car to travel 2,727 typical miles? So as I taught you, take a look, box in your numbers. Okay? So before you do anything, you should have boxed in your numbers. Let's read the questions. What the question says. Excuse me. How much gas would cost? So if you wanted to know, you want to look at for how much, so the unit right there should have a dollar sign. All right, so let's think of some process. First of all, you travel 7 miles per gallon. Oh, goodness. And so the car averages that. You have traveled that much. That's how many miles you travel. So how much gallons of gas did you use? Well, you would divide that by 27, okay? And so that comes out to be 2727 divided by 27. You have used 101 gallons of gas. And gas costs $4.04. So if you use that much, you would multiply them together times 4.04. And that means it's going to cost you $408.04. That's how you can figure out how much you need to spend on a trip. So the answer is D. All right. For this lesson, here are the words that you need to keep in mind. These are the vocabulary terms that you need to know. Point of intersection, systems of equations, linear system, inconsistent system, consistent system, independent system, and dependent system. So we will cover these terms, this vocabulary, as we go through the lesson today. All right, so let's go ahead and get started. First thing that you need is systems of equation. What is a system of equations? It's basically a set of two or more equations. So when you have two or more related unknowns is like X, Y, A, B, you may be able to represent the relationships with a system of equations. So a system of equation is a set of two or more equations, okay? But you have to have two unknowns. So for example, 2x plus y is equal to 9. There's one equation. Negative 4x minus 2y is equal to 12. There's the other equations. Can you have x, y, and z? Absolutely. Can you have A, B, C, D, E, F, and G? Absolutely. As long as there are two or more equations. Okay. Now, that is a system of equation. What makes it linear? By the way, this could also be 4x squared plus 2y equals 12. Okay, that is still a system. That's still a system of equations. All right, linear. What makes it a linear system is it's a system, but the highest power is x is to the first power. And also your y is to the first power. Kind of like a linear equation right here. This is in standard form. You could also have it in y equals 2x minus 4. Slope-intercept as well. So that's what makes it a linear system. It is because it is system that's linear. A solution of system, you might want to write all these vocab down, is a set of values for the variable that make all the equation true. So if I have two sets of systems, such as this one and another one like this, when I solve for them, say for example x is a number and y is a number, and I plug it in and makes both of them true, that makes it a solution of a system. Okay? So we'll come back and look at these again. You can solve a systems of equation graphically by using a table. You can all do it by substitution. So one is graphically table, two is substitution, and the third way is elimination. And I'm going to show you guys one more, but this is to help you in your ACT. And we're going to touch on matrix for just a little bit, but we're not going to go in depth into it until we hit that unit. So here are 4 ways you can solve for systems of equation. This one is wonderful when it's more than 2 variables, like 3 variables, 4 variables, 5 variables. And it's the way businesses put together and organize their system, and it's like an Excel. So just I'll let you know, but today we are going to stick with graphic and tables. Okay? All right. So let's take a look at first example. Here's your first example. We are going to solve this one by graphing. Now the easiest way to graph is to use slope-intercept form. That is the easiest way to graph. All right. So let's start off with this first one right here. Negative 3x plus 2y is equal to 8. Go ahead and rewrite it in slope-intercept form. So we're going to add 3x to both sides, divide by 2, so you have 3 over 2x plus 4. Okay, let's go ahead and graph this one. Now before I graph, I need to label my graph. 1, 2, 3, 4. 1, 2, 3, 4. Oh, I meant to go 5. 1, 2, 3, 4, 5. That's all right. Did I count it right? 1, 2, 3, 4. Yeah, okay. So this one, cross the x-axis at 4. Slope is 3 over 2, same as negative 3. Remember, over negative 2, negative is positive, so I'm going to use this one to go down. 1, 2, 3, negative 2, 1, 2. And there I have my graph of a line. All you really need is 2 points, but 3 makes it prettier. And it's a solid line because it's an equal sign, because we will be doing inequalities later. Okay? All right, let's take a look at this one. Okay? So you have x plus 2y equals negative 8. Solve for y. Subtract x from both sides. There's a 1 right here. Divide both sides by 2, so negative 1 over 2x. Negative 8 divided by 2 is negative 4. All right. So now we're going to graph that one. Negative 4. 1, 2, 3, 4. Negative 1, positive 2. To the right, 2. Okay? And if you want to, this could be a positive 1, negative 2. Means the same thing. So this slope could also be 1 over negative 2. Easiest way to graph. All right. Connect your points. And it helps if you use a ruler. Okay? All right. Now that you've done that, here you have your solution. So, you guys see that point right there? Let me get a highlighter. See that point? You see where they intersect? That point is 1, 2, 3, 4, negative 4, negative 2. That is called the point of intersection. Which is also your solution. That's going to work for both. So if I were to plug negative 4 and negative 2 in for this one, it's going to work. So let me show you. Negative 3, x is what value, times negative 4, plus 2, y is negative 2, equal. See how you have 8? And I plug into that one also. X is negative 4, plus 2 times y, which is negative 2, equals negative 8. Do you see how these two equations, let me move it up a little bit, x is negative 4 and y is negative 2, works for these. That's why that is the solution for both of them. And since it's a solution for both of them, that is your solution of a system. Point of intersection and solutions. Okay? And this here is an example of a linear system. Why is it linear? You have a line, one line, and then you have a second line. All right. So now let's go and see how we can use a table. Okay? When you use a table, it is best to use it in slope-intercept form. So, what you'll have is you'll have x, and you have y1 and y2. So we write them in slope-intercept form, and you're going to use your calculator. Okay? So how do I go? Well, I go to y equal. I'm going to clear what I've got. And if you want to, you can clear the whole thing, second plus 712, just to make sure you reset it. Second plus 712, okay? And that way you always know where you're going to be. All right, here we go. So I'm going to enter this one first. So parentheses, 3 divided by 2. Anytime you have a fraction, if you put parentheses around it, you'll never miss, plus 4. Your second one is parentheses, -1 divided by 2, x, here's the x you use, minus 4. And go to your table. Now notice table is in blue. So I hit to hit second graph. Okay? So we're going to go look and see where you can find your answers, where they're all, x and y should be the same. See how, I'm sorry, y1, y2 should be the same. You see how they're not the same? But I also already know my answer is -4, so I'm going to show you, go to -4. Notice how it's -2, -2 for both y1 and y2. So there is your solution. So your x is -4, -2, -2. These two should match. If that 2 matches, that tells you your solution is -4, -2. And there's your point of intersection. Okay? So that's how you can use a calculator. So I actually want to see this on your assignment so I know you got it right. And then you're going to have it by graphing as well. All right. Pause the video if you need to finish taking your notes. Okay? All right. Next part, let's look at example 2. Here's example 2. Okay? So we're going to do it by graphing, and then we're going to do it by table to double check our answers. So let's take a look at graphing. Here's your first one. X minus 2y is equal to 4. Put them in slope-intercept form. Subtract x from both sides, so -2y equals -x plus 4. Put a 1 if that helps you. Divide everything by -2. Each one of these by -2. Negative becomes a positive. Positive 4 divided by -2 is -2. Okay? So let me graph this real quick. 1, 2, 3, 4, 5. Make sure you label 1, 2, 3, 4, 5. Don't assume it's 1, 2, 3, 4, 5 every time, because that could be a 50. -2, y-intercept. Slope is 1 up, to the right 1. Okay? Use a graph, use a ruler, so your point of intersection is very important, so it can kind of help you find it. I would probably graph more than 2 points, just so that way when I draw my lines, it makes it pretty, just like that. But that's just me. Okay? But you really only need 2. All right. Let's look at this one also. 3x plus y equals 5. Subtract 3x. So y is, I like to write my slopes first, not required. Oh look, it's already solved. Y is a 1, so I'm done. Okay? Y is 5, y-intercept. Slope is -3 over 1. So 1, 2, 3, positive 1, 1, 2, 3, positive 1, 1, 2, 3, positive 1. See how I already got that? So your slope should always be consistent. It's a rate of change, and your rate do not change as far as like once you find it. All right, where is that point of intersection? Right here. And that is at 2, -1. So x is equal to 2, y is -1, and you can write it as an ordered pair. It is actually a point, so there's your solution. Okay? Now let's go to our table. Let me pick a different color. Let's go to our table. Table, you will use a calculator. You should have x, y1, y2. So it's a way to check your answers. Clear, clear, clear. Just like that. Okay? All right. Type in the first one, parentheses, 1 divided by 2x minus 2. Your second one is -3x. It's not a fraction. I can keep it just like that. Plus 5, second table. And I know my answer is already 2, so I'm just going to double check. 2, see how they match? None of the others match. -1, -1. So 2, -1, -1. So your solution is 2 and -1. That's going to work for both of these. That's your point of intersection, that's your solution, 1 point. All right. So now, some things I also want to point out is when you are graphing, I can't remember if I put this on the example, if your lines are parallel, okay, you will have no solution because they never cross. Just keep that in mind, all right? If you are graphing and it is one line on top of the other, just like that, they're exactly the same, your answer is infinitely many solution. So hopefully we'll talk about that in just a little bit. All right. Okay. Now, we're going to talk about a consistent and inconsistent solution. Okay? So here we go. Oh, I do have it right here. Okay. So let's take a look real quick. Give me just a moment. Let me pull this up. Okay, so if you have a graph, I'm going to draw 3 graphs. And I'm just going to make a sketch. 1, 2, 3. Okay? All right, here we go. If you have a graph that we've been graphing, here's one line, here's another line. Notice they have one intersection. If it's one intersection, that means you have one solution, okay? And if you have one solution, it is going to be consistent and also independent. And I'm going to abbreviate. We're going to talk about this down here in just a little bit, okay? So you'll take note on that. But it might be good for you just to see a graph to visually see. If you have a graph that it's one line, the other line is right on top of it, it's the same line, okay? The answer point is you have infinitely many solution. Another way you can write that is the 2 lines with an R. It means all real numbers. What does that mean? That means this is consistent and this is, they depend on each other. One on top of the other, okay? So that's a graph. If you have a graph, when you're graphing, you have a line, and then you have another line, and they never cross. So basically, these are parallel, and when they're parallel, they have the same slope, okay? M is the same. Your slope is the same, not perpendicular, parallel, same slope. What does that mean? This one means it has no solution. And a symbol for no solution is a 0 with a line crossing it. That means it is inconsistent because they will never have the same answer. So if here's a way you could write it. Here is a bracket form. If something is consistent, okay, it will either be independent or dependent. If it's independent, you have one solution. If it's dependent, you have many solutions. You guys got that? If it is an inconsistent system, you just have no solution. So consistent can be one solution or many. Inconsistent, you have none. So these are a way you can kind of look at it. Here's another way you can look at it on a graph as well. You might want to pause, make sure you know these words and understand what they mean. Okay? All right. Let's look at example 3. We have a word problem here, and I'm so sorry that you can't see that very well, but let me see if I can make it a little bit better on that part. Here we go. All right. So here's a growth rate. So there's your M. Here's the birth. Here's your B. Okay? Here's a growth rate. Here's your B. So you guys got that real quick? So it says, the diagram shows the birth lengths and growth rate of 2 species of shark. One of them is called the Greenland shark. The other one's called the spiny dogfish shark. Okay? So I'm just trying to let you guys see a little. Step 1 says you need to define the variable. So they're going to let x be the age in years and y be the length in centimeters. So how would you write the equation? So let's look at the Greenland shark real quick. Maybe I should have done that in green. How would you write that? So x is years, length is centimeters, okay? So how big is it going to be when the shark grows in how much? At a rate of 0.75 x, but when they're first born, they're 37. There's their beginning point. The other shark, the spiny shark, y, how big is it going to be when they are growing at 1.5 centimeters per year, but when they're born, they're 22. Now, we know sharks don't keep growing for their whole life, just like human, right? But for this scenario, we're going to pretend they do. So just, that's the limitations you have with linear. Just keep that in mind. But we know sharks in real life don't grow forever until they die, okay? Because at a certain point, we all shrink when we reach our maximum. Just, there you go. Okay, now I want you guys to use a table to solve the problem instead, okay? So how would I go about that? I'm going to move my calculator, my camera back a little so you guys can kind of see the calculator. Okay, you guys see that? Give it just a moment. Here we go. Y equal, clear, and clear. Remember what to look for. 0.75 x plus 37, 1.5 x plus 22. Now, I want you to think about, we're looking for something how long it is. Can you have something be a negative if you're trying to find the length of something? No, it would always be a positive. So second table. We're going to go see where we can look. See how I'm starting at negative? You can't say, oh, I was born -4 years. No, you always start at 0. So we're going to go look for a positive, and we're going to try to find where they will match up. Okay? So far, do you see it? We're heading in the right direction. Oh, look at that, 52, 52. So how long is it going to take for them to be both 52 centimeters long in 20 years? Okay, so you have this, x, y1, y2, and you have 20, 52, 52. Let's see what it means. This means that in 20 years, because it was per year, in 20 years, both sharks will be exactly the same length, 52 centimeters. So that's what that means. In 20 years, both sharks will be 52 centimeters. Okay? So if you wanted to know when they're going to be about the same, notice the rate of change is different. One grows at 0.75 centimeters, the other one grows at 1.5. And when they were first born, they were both also different. This one was smaller than this one, but eventually they caught up. All right, let's answer A. If the growth rate continues, how long will its shark be when it is 25 years old? Okay, so notice this is the year, so this year 20. So let's go to 25. We're going to use our calculator as a table. Did you guys see that? We have this one under Y1 and we have this one under Y2. Okay? So according to our calculator, the Greenland shark in 25 years will be how long? It's in Y1. 55.75, don't forget your units, centimeters. And how long is the spiny shark going to be in 25 years? 59.5 centimeters. Notice he started off smaller, but he's going to get longer, quicker. Okay? Explain why growth rate for these sharks may not continue indefinitely. Well, we all know things hit a maximum, and then most things starts to shrink, even people. You notice your grandparents gets a little shorter. And then it leads to, I hate to talk about it, but eventually they die. So that's why they don't go on forever. Indefinitely means forever. Okay? There's your symbol for infinitely, or infinity. There you go. So, all right, let's look at example 4. We're going to try to define if something is consistent, inconsistent, or independent. And the way you can do it is you can always compare slopes and the y-intercept. So here we go. Let's take a look at this very first one. I'm going to rewrite this in slope-intercept form. Okay, so I'm going to solve for y. So I have 4y is equal to plus 2x, so 2x plus 6. Y is equal to 1/2 x plus 3 over 2. Okay? Get another color. All right. Now I'm going to do this other one also. This one, I have 8y equals 4x minus 12. Divide by 8, so y is equal to 1/2 x minus 3. Negative 12 divided by 8. Oh, I'm so sorry. That is actually 3 over 2. Oh, your teacher just screwed up. You know, it happens, right? So this was dividing by negative. Hang on just a moment. Let me double check. So this is plus 2 divided by 4. Nope, it's correct. Okay. All right. Compare. What do you notice about the slope? Both slope is 1/2. So what does that tell you? That right now it can either be parallel or it could be one line. Okay? Think about it. Question, question. Let's take a look at your y-intercept. See the y-intercept? We'll call this one 1. You call that one 2. y1 has a b of 3 over 2. y2 has a b of negative 3 over 2. Are they exactly the same? No. Slope's the same, y-intercept's different. That tells you it's a parallel line. If this had been the same, it would have been same line. So, knowing that, what kind of systems do you have? Well, if it's a parallel line, they never cross, they have no solution, so that would be inconsistent. Okay? So this is parallel lines, no solution, and since they have no solution, this would be inconsistent. So there you go. All right, let's look at example 5 and see if we can tell if they're independent, dependent. If they're independent, you know they're consistent. Here we go. All right, you guys ready? Let's look at A. Let's take a look at the first one. Negative 3x plus y equals 4. Solve for y. So y is equal to 3x plus 4. And I'm going to box it in. I'm going to call this one 1. Take a look at your second one. Okay, right here. So you have negative 1/3 y equals negative x plus 1. I subtract 1 from both sides. Times it by 3. And I'm actually going to multiply it times negative 3 so I can get rid of the negative. Now, when you multiply times negative 3, you got to multiply the whole thing. Y equals negative times negative is positive 3x. Negative 3 times 1 is negative 3. Let's go ahead and compare, and I'm actually going to get a yellow highlighter because that one's a little harder to see. The pink, because I'm writing in red. What do you know about slope? Same slope. If it's the same slope, it's either going to be parallel or one line. Okay? Oh, let me finish real quick. All right, that was the bell. Now let's take a look at our y-intercept. Are they the same or they're different? Well, they're different, so that means when you graph them, the lines are the same, but they're going to cross the different y-axis, so that tells you that it's parallel. And when something is parallel, guess what the solution is? Inconsistent. Okay? There you go. All right. I'm going to pause right here. I have students coming in. I will finish the second part. We'll finish the rest of this, and then I will upload both videos. So this is part A and this is part B. So we'll finish it in just a little bit.